So we start with another topic called the tokenization. So in this topic, right, we'll define what is tokenization, why the tokenization is required. So in tokenization, so the definition of the tokenization is the process of breaking the small text into the smaller units, which we call the tokens. For example, like words, subwords, characters, or sentences. So if you see like in summary, like how I can define this tokenization, so is processing the text like list of meaningful elements which actually I break into tokens or chunks of subwords. So for example, I am providing a input here, like this machine learning is a powerful. So I kind of a split into chunks like machine learning is powerful. Okay, so like that we can split into different chunks of words. So basically in each token it has a small unit for analyzing in natural language processing. Now obviously we will ask why tokenization is required. So first the tokenization is the first step in the NLP, and we obviously know that it is actually useful in the text processing. So it actually helps the computer to understand the human language by converting raw text, right? So it's basically raw text converting into a structured form. Okay, so it has certain properties like breaking the unstructured text into a manageable parts, right, which we call the tokens or chunks, right? So it also helps like converting the text into a numerical features. So basically what about the tokens we are getting, right? It actually later on we have to provide the token ID. So how to find the token ID, right? We'll see in the next lecture. Next part is that it builds a set of unique words and tokens. It also enables the counting of the words like using the IDF mechanism, right, which we'll also discuss in the subsequent lecture. Tokens are also mapped for the word embedding of the indices, right, and also provides a separation of the meaningful word from punctuation and the symbol. So for example, here if you see NLP is amazing, there is no space. So if I do the tokenizations, right, it actually split these entire characters, right, into different chunks of data. Okay, so next part is that there are different type of tokenization. So one is the word tokenization. So in this word tokenization splits the text into individual word. For example, I love AI, so I love AI, and also for the full stop. So similarly for the sentence tokenization, split into sentences. I love AI, it's an amazing. So I love AI is one token, it is amazing is another token. Character token, so it takes the character chunks, right? So splitting the text into the individual character, like for example NLP. So individual character is actually split here. So similarly for the subwords token, splits words into a smaller meaningful units. So for example, in subwords tokenization, unbelievable. So un is one token, BELIEV is one token, ABLE is another token. Next is the byte pair encoding. So based on most frequent symbols, so we'll explain in details for the byte pair encoding topic. So it's basically like, for example, I'm providing a lowering, so it actually does the tokenization as low, E, R, and ing. Next is the word and the sentence piece. So it is used in the BART and GPT, right? For example, right, playing. So I chunk it like a play, and here is another chunk, right, which we have represented here. So let's come to the word tokenizations in Python, right? How it is actually look, right? So you have to import from the NL toolkit, right, where I import the word token. Nice. So I provide the text here as an input and print the word tokenization. So the output is providing as a machine learning is useful. Okay, and this is also another chunk. In the sentence tokenization, so for NLTK toolkit is send tokenize is the representation which we have to import. So we provide the text input here, right, where text input is AI is fun, fascinating, and it is challenging. It is changing the world. So if we print the output, right, it is fascinating, right? So this is one token, and it is changing the world. Sorry. So this is another token, right, which is can be represented in the sentence tokenization in character. So if I provide the input AI, so obviously, like that I mentioned right earlier, right, in the character tokenization. So you can see here, right. So it divides A and I as a chunks of token. Next, coming to different model used in the tokenization, one is the BART model, GPT base we can use, GPT-2 or 3 also can be used. Sentence speech, which actually takes the T5, that is text to text transform model, is another model which can be used in the sentence speech. So basically, it does the word piece tokenization in the BART. In GPT, it uses byte pair encoding. In T5 model, it does the kind of subpart tokenization without vice present dependency. So here, it's actually basically in the sentence piece. It also uses the BP. Another model is called Unigram. Okay. So these are certain examples, right, which we also already have discussed. So let's come to an kind of example here. AI is powerful. So what tokens here is AI is one token, is another token, power, and this is another token. So the numerical representations of these tokens is 464, 318, 11375 and 0, right? How we are getting this? We'll discuss in later lecture, right? So we'll use the BP model or algorithm to find the or provide the numerical ID. Okay, so this is all about the tokenization concepts. Okay, please subscribe my channel. Thank you.